Okay, quick flex. I'm about to make a vitamin glow like a highlighter. Watch this. I drop a vitamin B2 tablet into water, hit it with a black light, and boom, bright yellow glow. Why? First, the myth bust. It's not radioactive, it's not going bad, and your pee isn't neon because you're super hydrated. What's really happening is a gorgeous little physics meets chemistry trick called fluorescence. Vitamin B2, aka riboflavin, has a flat ringy part called an isoaloxazine ring, basically a tiny solar panel for certain colors of light. When blue or UV light hits it, those electrons get excited to a higher energy state. Then they relax and spit that energy back out as light, but at a slightly longer wavelength. That shift is called the Stokes shift, and in riboflavin it lands in the yellow-green zone. That's the glow. Okay, but it looks yellow even without the black light. Right, riboflavin is naturally yellow because it absorbs blue light and lets more yellow through. The black light or strong blue flashlight just turbocharges the effect by kicking those electrons up a level so they can re-emit that signature yellow. Here's a quick test you can try. Glass 1, plain water. Glass 2, vitamin B2 in water. Glass 3, tonic water. Shine a black light. B2 pops yellow. Tonic water glows blue because of quinine. Same fluorescent principle, different molecules, different colors. Now, the P question, because I know you're thinking it. Normal urine is yellow from urobilin, a breakdown product of hemoglobin. But take a B complex or riboflavin supplement, and you might get that highlighter yellow look. That's extra B2 your body doesn't need, getting excreted. And yes, under strong blue UV light, it fluoresces too. It's not toxic glow, it's just fluorescence plus excess vitamin. A few nerdy knobs you can turn. Light color. Blue, UV, in. Yellow, green, out. White room lights won't show much glow. pH, around neutral, the glow sings. Very acidic or basic can dim it. Oxygen and time. Riboflavin photobleaches, leave it under light, and it slowly breaks into less glowy molecules like lumichrome. Heat and storage. Heat and light speed that fade. Keep vitamin solutions cool and out of direct light if you actually care about the glow. Zooming in, that isoaloxazine ring is loaded with alternating bonds, lots of delocalized electrons. Those electrons make it easy to absorb one color and re-emit another, which is the heart of fluorescence. Nature uses this trick all over. Scorpions, coral, even laundry detergents. Riboflavin is just the kitchen-safe version you can demo tonight. So the headline, Vitamin B2 glows bright yellow in water because its molecular structure grabs energy from blue, UV light, and re-emits it as yellow-green. Not magic, not radiation, just beautiful physics wearing a chemistry costume. If you try this at home, use a cheap blacklight flashlight, dim the room, and compare it with tonic water to see different colors. Bonus points if you time how long it takes to fade. Photo bleach speedrun. Alright, you now officially know why your multivitamin can moonlight as a glow stick. Hit like if you love tiny science flexes, and I'll see you in the next experiment.